Okay, so here's the second part. The second part is called solving using elimination. Okay, so the first thing we did is we solved using substitution and we used graphing. We used graphing, you notice it was quicker, less accurate. Elimination, substitution, you had to deal with some fractions and move things around and get it equal to y and then put them equal to each other. A little bit more hassle. This next way is called elimination. By far the easiest to do. You can solve systems any way in which you wish to do. I try to solve them all using elimination. But there are going to be times when one is easier than the other. And that's what 6-3 and 6-4 deal with. Meaning looking at an equation and understanding, hey, which one's going to be easier to do? Which one can I get done faster? There is no correct way. There is no wrong way. You can use either way. But the understanding is that you must find a way and get an answer, whichever way you wish to use. I will tell you, though, that as we're getting into elimination problems, you'll start to go, well, why didn't we just learn about this first and nothing else? You have to understand all of the process. In other words, that one is better than the other in certain situations, and one is not. One is quicker, one is not. If you feel more comfortable with elimination and only elimination, then you can use it every single time. That's not an issue. I don't have a problem with that. I'm just letting you know that when we do the computer software, they're going to ask you to do both ways, so you need to know how to do both ways. Okay? You need to know how to do both ways. That doesn't mean you have to always use both ways. All right, so you have to understand the rules of getting rid of fractions and decimals, because those still exist. And elimination is used when things are written in standard form. So you don't write them in standard form, it's very difficult to try and eliminate. If they're already in slope-intercept form, it's easier to just put them equal to each other and go. If they're both in standard form, then elimination becomes an easier tool. So I'm going to take a question from the book. Okay. And we're going to solve this system using elimination. Meaning, I'm going to solve for the break-even point or the point of intersection. Okay. And I'm going to get this answer by looking for a few things. When I use elimination, the idea is to first find opposite signs. So when I'm looking in this problem, do any of these have opposite signs? That means the x and the y. Well, this is 10x and 15y, and this is 5x and 6y. Well, these don't have any opposites. So I don't have anything that's opposites. Okay. 2, make opposites. So how am I going to make opposites? So if this is 10x, what's the opposite of 10x? Negative 10x. 15y, what's the opposite of 15y? Negative 15y. Which one is going to be easier to make opposites? Hopefully you're answering in your head, 5x is easier to make opposite. Now remember, in algebra we learned one concept, and one big one. If I change one thing, I have to change everything in the same problem. So to make this an opposite, it would be negative 2. So if I multiply this by negative 2, I have to multiply this by negative 2, and I have to multiply this by negative 2. So now I have my first equation, and then the second equation, I made the x's opposite. Now you can make either one opposite, but make it easy on yourself. Make the one that's easier to do. Okay? The opposite of 10x, 5 can get into 10 really easily. 6 does not go into 15. 6 goes into 30, so you'd have to change both equations. We don't want to mess with that. Try to do the easiest. So this would be negative 10x, negative 12y, and 8.5 times negative 2 is negative 17. Okay? And then with elimination, all you do is add straight down. And the reason they call it elimination is because you're eliminating one of the variables. Okay, so I'm eliminating x in this case, which means I'm solving for y. 15 minus 12 is 3y equals 20 minus 17 is 3. I divide the whole thing by 3 and I get y equals 1. So now I have an answer for y. But remember, when we are solving for any of these, we are finding the intersection. We are finding the break-even point. I must always do two problems. I'm solving for x and solving for y. In this case, I solved for y first. Now I have to solve for x. And I go back and plug this in to either one of the original equations. Doesn't matter which one? Nope. Which one would I pick? Hopefully you pick the one with the smaller numbers. So it would be 5x plus 6y equals 8.5. And I'm now going to plug this y into that equation. So I'm left with 5x plus 6 times 1. I'm going to write it like this. 8.5. Okay. Hopefully you know 6 times 1 is 6. Then we do our lovely mad algebra skills. Minus 6 from both sides. Right? Move this over here. And I'm left with 5x equals 2.5. Divide the whole thing by 5. You get x equals correct, 5. So now I know my point of intersection is 0.51. The x being here, your y being here. Okay, because it's an ordered pair. So in elimination, we try to find opposite signs, hoping that they're opposites already. And if we don't have any opposite signs, we now have to make opposites. We might find opposite signs and not have to make opposites. If we already have opposites and opposite signs, we're good. We just go ahead and add straight down and solve for one of the variables, plug it back in and solve for the other. This process becomes easier the more you do it. So we're going to do plenty of these. And like I said, by the time we're done, you'll be able to pick which way you want to do. But this, you will find that when a problem is given to you, many times it's easier to eliminate than it is to substitute. Substitution takes a little bit more time, and it's easier to make a mistake. Elimination, you could see, bam, 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 got the answer. Okay? But based on Unit 3 rules. So if you have a firm grasp of Unit 3, you usually do pretty good in Unit 6. If you don't, you're going to have to know both. And you're going to have to practice. Practice, 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 practice. Okay? It's called solving using elimination. All right, hopefully you come on Monday, and if you have any questions, we'll go through it. The harder part is going to be writing the two functions to begin with. So we'll go through and practice that. But once you have the functions, you should be able to solve using elimination or substitution. All right? Okay, 6.3 and 6.4, I'm not going to do a video for, because 6.3 and 6.4 use the same concepts and ask you to solve using whichever method you choose to use. Okay, and it's just more of getting rid of fractions and transforming problems. So that's what we're really working on. Getting rid of fractions, getting rid of decimals, and then figuring out which way is the best way to do certain problems. All right? So we have systems of linear equations, which is what all these are. We have the substitution method, and we have linear combination method, which is called elimination. Okay. The reason they call it elimination is because you eliminate one of the variables, solve for one, and plug it back in, and then solve for the other. I call it the Glade process, like the song. Plug it in, plug it in. You're never going to find just one answer. You got to turn around and plug it in and find a second answer. Why? Because your point is 2 coordinates. It's never just one, unless the other one's 0, but it's still 2 coordinates. All right, guys? Have a good end of the break, and we'll see you on Monday. All right.